Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for Throwback Thursday. About 66.25 million years ago, a series of fissures erupted, spewing lava for 500,000 square miles, or about 1.5 million square kilometers. During the Cretaceous, India was an isolated landmass just drifting across the Tethys Ocean. Now, here's a map that'll kind of help give you an idea of what this looked like. India had broken off of Gondwana during the Jurassic period. During the Cretaceous, it was connected to Madagascar and Seychelles, right up until the Deccan traps erupted. Coincidence? I think not. Not really. The eruptions occurred over a time span of about 600 to 800,000 years, crossing right over the Cretaceous-Paleogene extinction event. And there are a couple of ideas on how the Deccan traps formed, either due to rifting of the seafloor or a mantle plume. Most data seem to point toward the mantle plume hypothesis. In the Indian Ocean currently, situated under the Mascarene Islands, is the Réunion hotspot. India would have passed right over it during the late Cretaceous period. Regional crustal thinning in the area could encourage the rise of a mantle plume, and when comparing the sodium, iron, and siliconate contents of the Deccan traps to other major igneous provinces, the Deccan appear to have undergone the greatest degree of melting, suggesting a deep plume origin. And if you didn't get to see the video on the igneous provinces, the LAPs, I suggest you go check it out. It'll tell you a little bit more about those deep mantle plumes that come from the core boundary. The motion of the Indian tectonic plate and the eruptive history of the Deccan traps also show strong correlations. Based on data from marine magnetic profiles, a pulse of unusually rapid plate motion began at about the same time as the first pulse of the Deccan flood basalts, which is dated to about 67 million years ago. The spreading rate rapidly increased and reached a maximum at the same time as the peak basaltic eruptions. And the spreading rate then dropped off with the decrease occurring around 63 million years ago, by which time the main phase of the Deccan volcanism had ended. And this correlation is seen to be driven by plume dynamics. And it makes sense, as you're coming up over this plume, volcanism would start. As you're sitting basically right on top of it, that would be when most of it was happening, and as you're coming off of it, it would start to end. As stated in last week's Monday Musings, many LIPs have been correlated with extraterrestrial impacts events. And although the Deccan traps began erupting well before the impact of the Chicxulub, in a 2015 study, it was proposed, based on argon-argon dating, that the impact may have caused an increase in permeability that allowed magma to reach the surface and produced the most voluminous flows, accounting for around 70% of the volume. Now, whether the traps played a part in the greater extinction event or not, the traps certainly had a catastrophic effect on the flora and fauna of the Indian subcontinent. Almost all the vertebrate lineages were driven to extinction, including the dinosaurs that lived there. Only 3 extant tetrapod groups can be verified as having Gondwanan ties that currently live in India. We have one family of kind of goofy-looking frogs, a few caecilians, and one family of blind snakes. Interestingly, all of these have a fossorial way of living that may have saved them from the extinction event. And all that really means is that they lived underground. They are burrowers, and honestly, it's one of the ideas for what saved things during the extinction event in general, that either they were generalists or they lived underground, or both. Well, thanks for coming to today's lesson. Hope you enjoyed it. Tune in tomorrow to learn more about Paraceratherium. Fossilize you later.